Okay, here on number 2, we've got an order for sulfexime suspension, 0.4 grams by mouth every 12 hours. And we need to figure out how many milliliters we're going to get. Okay, so let's start with our desired answer. We want to know milliliters, right? And again, I'm going to push you to start doing, writing it as a milliliter per dose. Okay, so we can understand that we're calculating milliliter per dose, that this specific dose that we're fixing to go give the patient, we're asking how many milliliters per dose. Next, we need to identify the unit dose metric concentration that's on the label. Okay, so looking at your label for Suprax, and that's just it's not the same name that's on the order. I mean, the order is written on that label as well, but it won't always be. Okay, it's a trade name versus generic name difference. So that trade name is going to have the little registered trademark behind it, that little R with the circle around it. That's going to be your trade name. The other one is your generic name. And usually they'll big and bold the trade name. Okay, that's the important one. And sometimes they may have that generic name listed, smaller case, written below it, so on and so forth. Okay, on the Suprax label, you can see that they're telling us that 200 milligrams is in 5 milliliters. Now, this whole bottle contains 25 milliliters once it's been reconstituted. We're going to talk about that in chapter 7, I think. But anyways, the whole bottle is going to have 25 milliliters in it. But each 5 milliliters of that 25 is going to have 200 milligrams of medication. Okay. So when we're looking for our first fraction for this dimensional analysis, we want to put milliliters at the top, right? So from your label, we're going to pick up that 5 mil is 200 milligrams. Now that puts milligrams at the bottom, which means we need milligrams at the top of our next fraction. Our order is where we typically look for that, but the order is written in grams, and we need milligrams. So there's an indicator to you that we need a conversion factor. We got to convert milligrams into grams, okay? Now again, we have milligrams at the bottom, so that means we need milligrams at the top. So back in week 2, I had a Word document with a bunch of conversion factors that I needed you to memorize. On that list, it'll tell you that 1,000 milligrams is 1 gram. Okay, so we've got milligrams at the bottom, we've got milligrams at the top, they're going to be able to cancel. Now that put grams at the bottom, which means our next fraction needs to have grams at the top. So let's stack that as from our order. We need to give 0.4 grams. And again, we need that as a fraction, right? Typically we were just putting it over 1. Go ahead and get used to the idea of putting it over the word dose. Okay, 0.4 grams per dose. That's what we have to give our patient every time we give a dose. Okay, so I think we've got the setup. Let's check our units. The milligrams are going to cancel, the grams are going to cancel, so we have milliliter on top and dose on bottom. And that is what we were looking for, right? So we've got the right setup. Now we can multiply. 5 times 1,000 times 0.4 is 2,000. 200 times 1 is 200. And divide those, and we should be getting a 10 milliliter per dose. Okay. I want to go a little bit further with these and ask you some more questions about this stuff. Let me find my questions. Okay, so yes, we're going to give 10 milliliters per dose. So every time you walk into that patient's room to give this medication, you give 10 milliliters at a time. How many times a day are you giving that medication? How many doses does that patient need in a day? So this is where we're going to go back up here to the order and look at that Q12H. Q12H stands for that's every 12 hours. Okay, so let's see if I can move this, sorry. Okay, Q12H means that that's every 12 hours. There's 24 hours in a day. If we divide that by the 12, then we know that we're going to give this medication 2 times a day. Okay, so every 12 hours happens 2 times a day. Now, what if I asked you, we know we're given this 10 milliliter per dose, and that's going to have to happen 2 times a day. So we figured out milliliter per dose, right? What if I asked you to find milliliter per day? Well, milliliter per day, again, let's think about this using dimensional analysis. We need to stack some milliliters at the top, right? So go back here to your answer. We said we know we're going to give 10 milliliters per dose, And we just looked at the blue part over here that says we've got to give this dose 2 times a day, right? So we're going to give 2 doses in a single day. And check your units. The doses get a cancel. And look at there, we have milliliter on top, day on bottom. So we're ready to do the math. And we get 10 times 2 is 20. So we're given 10 milliliters per dose, but overall that's going to be 20 milliliters per day. Okay, so get used to writing it as a per dose or a per day, whatever your question's asking for there. Now you might also see a question that asks, how many grams of Suprax will the patient receive in 24 hours? Well, our order up here says we're given the cefixime, which that is Suprax, okay? So we're given this medication 0.4 grams every 12 hours. We want to know how many grams will the patient receive in 24 hours, okay? So this is 0.4 grams per dose, right? We've got to figure it out per day, how much in 24 hours. So let's go back to some dimensional analysis. We need to calculate grams per day. Well, our order said 0.4 grams per dose, and over here in the blue, we were looking at the fact that we're given 2 doses in a day, right? So, of course, your doses get a cancel, and you get gram per day, which is what we were looking for. So we do the math. 0.4 times 2 is a 0.8. So we give 0.8 grams per day, but it's happening at 0.4 grams per dose.